Okay, so on this problem, you want to see what kind of particle it is. This is a proton, so it's positive. Okay, protons are positively charged, right? And it's moving up the page, right? And ultimately what's going to happen is that it's got a magnetic field out of the page, right? Okay, in that magnetic field out of the page, oh, I hate that. There, I can't write on it, okay? In that magnetic field, let's draw a picture of it going up the page because it talks about in the next problem the thing going up the page, right? If it's going that way, I put my index finger this way, right? Because that's the direction of the current, right? The magnetic field is out of the page, so my middle finger is this is our magnetic field, right? Okay, that's my middle finger. Okay, my middle finger is out of the page. Okay, my thumb is to the right, so the force, the magnetic force on this thing is this way. Okay, the magnetic force will be to the right, so that means that this thing's going to go in a circle like this. Okay, it's going to go clockwise. So we've now answered this, which way did it go? It's clockwise, right? This is my thumb, right, of my right hand. So that's how I figure out that it's clockwise. To figure out the radius, what you do is you say, okay, force is equal to QVB. Well, Q just got kind of crazy, right? And there's a 90-degree angle, so the sine of the angle goes away, right? And then also force is equal to MA is equal to, in this case, MV squared over R. Right? So the construct here is just QVB. What these particles do in magnetic fields is they spiral. When they hit a magnetic field, they spiral. In fact, charged particles coming from space spiral around, they go around the magnetic field lines. Well, since magnetic field lines originate or emanate from the North Pole, which is the South Pole of the Earth, right? And then go into the South Pole, right? Basically, charged particles from space will spiral around those magnetic field lines and hit either the North or South Pole, making the atmosphere glow, which is the northern lights, which is kind of interesting. You didn't need to know that to solve this thing. Let's see, mv squared over r. Okay, so basically, electric force or magnetic force equals centripetal force, right? Notice that we can cancel a v. What are we solving for? Radius of its path, right? So we're trying to solve for r. R is going to be momentum, somewhat surprisingly, over QB, right? Okay, so that equals, and then you got to look it up, right? It's like, what is it, right? In your data packet, you'll see that the mass of a proton is 1.673 times 10 to the minus 27th kilograms. That's why you've got a data packet, right? Okay, the velocity is 1.71 times 10 to the, 10 to the fifth. When my computer checked for email or something there, right? Okay. Holy chunking Batman, okay. And then the charge of a proton is the same as an electron, so 1.602 times 10 to the minus 19th coulombs. Okay, and then our magnetic field is 2.30 Teslas. All right. No, my batteries are low. Good enough. 1.673 times 10 to the minus 27th, okay, times 1.71 times 10 to the 5th, right, divided by, and then I'm going to do, I have to put this denominator in parentheses, so 1.602 e to the minus 19th times 2.3, yeah, and I get 7.764 times 10 to the minus 4th meters, which is, there we go, right? Okay. All right. Good enough. I think we got it, right?